So let's try to understand what is thread variable, which was a part of previous video, but since the video was quite long, so we have taken in this video. So variable which is required by thread, or thread which is taking input of a resource called thread variable. This variable may be of primitive type or object type. So condition, when any thread variable may be required by number of threads, there may be a waiting of threads. So quite clear that when a variable is required by a number of threads, or a resource which is required by a number of threads, there may be a waiting of a resource. So on that case, threads will simply try to fetch the resource, and if someone has got the resource, then he will simply execute the code and rest will wait. So there may be a certain problem. There may be a problem like number of threads will be in a wait state. So it means the thread for which they have been assigned, there will be the stopped. Like the work will be stopped, or it will simply important the hamper the performance of a whole program. So any variable which is required by a thread. So thread is a class and its object is a simply thread, and that thread may have a number of fields which may be used to create an object. So that object, if required by a number of resource, or if have some problem of if it's scarce, then there may be a waiting of a threads. So if suppose a resource is required by number of threads, on that case, since the thread scheduling is completely random and simply not predictable, then when which thread will get start and when which thread will start execution. And suppose if we are not making sure that the resource allocated to a thread will be allocated till the work is getting completed, on that case it may be possible that the resource uh, anytime during the execution may get emptied and may be allocated to someone else. So halfway work, it means if the thread has completed its work halfway, on that also on the in the case also the variable required by another thread may get allotted, and on that case other thread may also get start. At the same time, if it is also halfway, then another thread may also get allocated. So this will be a simply hodgepodge condition. This is simply unavoidable, and it is not required in a good program. So how we can assign, how we can ensure that the variable or a statement or a method which is critical, which is required by all, need to be allocated for a thread for the period till the work has been executed. So the way to avoid race condition is called synchronization, and here the block or a method will be called synchronized block. So when two or more threads are used to share resource, then these threads are reading and updating the variable. In this case, reading and updating the variable mean to say, if the suppose one thread is acquiring a particular variable, so it is taking the value of a variable, and after modification or executing of work, it is simply updating the value of variable, and in the meantime another thread is also getting the same variable. So it will take that value that has been manipulated by the previous thread. So this is reading and updating the value is going in a not in a unsynchronized way. So on that case, the result will also be unsynchronized or unpredictable. In this case, there may be a race condition. Variable may be allocated to any thread randomly. Then it will create some unexpected result. Okay. So there are two ways to avoid this condition. Either the object pass separately, no shared object. Of course, if there will be no sharing, there will be no problem, no interference, no race condition. And if the object is shared or used by someone, so on that there may be a conflict. How much time you will be take, how much time that will take. So there may be a conflict, on that will be a race condition. Each time the thread will be in wait state, and it will be simply not clear that when the thread will get start or when the thread war will get complete. So there may be a race condition, and to avoid this, the code may be synchronized. So synchronized object or a statement will be allotted to only one thread at a time. Once this thread will complete the work and then it will be allotted to other, there will not be any race condition. So each object has intrinsic lock which will be kept to current thread, means it will not be passed to another thread till the work is over. So any object, all kind of objects have its intrinsic lock, and thread which will acquire the object will keep its lock, and it will keep the lock till the object allotted to that thread till the work is getting completed, and after that the work is over, it will release the lock and that will be taken by another thread. So this will be simply token type of system where it will be ensured that the object is kept by some thread, so everybody is getting acknowledge that the object is kept by that thread. So in that case, there may be no discrepancy, and the system will get that the work is done or work is on by that particular thread. So there will be no any kind of discrimination. So let me try to understand this by some code. So let me take an example where a thread variable required by number of threads. So that variable may be of object type. So for doing so, let me create a class uh, countdown. So this class will simply do uh, a counting work for suppose 10 or 15. So let me take 10. So this is a class, and class we can say count down. Okay. So this is a class, and here let me take and in this class let me try to make a method, and that may be public void do counting. So this is a counting method, and this method will do what? So it will have a switch statement. This switch statement will simply choose what color. Okay, there is no. This switch statement will simply switch based on thread. So thread name dot current thread dot get name. So it will simply based on so is thread 1. Okay. And what it will do is simply it will give the color. We have to let me assign a color, and that will be color will be the class thread color dot, suppose we are assigning first Shan. Okay, Now what we want to do, this will simply no, only we want to assign a color. Okay, and let it break. Later on you will see what we have to do. Okay, case, and this is thread 2. Okay, thread 2, and this color will be thread color dot what it is. Let me assign it purple. Okay, and this will be operate. Now this will be a default condition, and here is default color will be what thread color dot, and suppose here we are giving it green. Okay, and now here we have to make a for loop, and this will be a exit of switch statement. After that there will be a for loop, and that will have a suppose we want a counting up to n, and then I plus plus. Okay, so and what we want to do here, color plus name suppose. Okay, so we want to predict this is the color and the thread name, and the color assigned to a thread, and this is the name of, and this is how much counting and which thread has done counting the value of y, this one. So by when we will call this method, it will simply choose the thread, and based on the thread we will create object of thread, and based on the thread name it will simply assign a color of a string variable, and after that exiting a switch loop, and there will be a for loop, and this for loop will simply start counting from 1 to 10, and after that it will simply assign the color and thread name, and so this object of this countdown will be taken by number of objects. So let me create a thread class. So countdown thread, this is a thread class, extend set. So here suppose let me check the countdown. Okay, so we have created an object of type countdown. Okay, and here we have created a, so this may be, then why it is showing, this is countdown, this is, and this is, okay, this is object, and let me create a constructor, and here constructor is taking object of this one, and this dot countdown is the parameter assigned to this one, and this is a run method, and the run method is simply doing what? It is simply calling the object method do counting. Okay, so we have created a thread, we have created a class, and the thread is now having a variable of type countdown. This is important. This variable will simply create a difference, that this is a thread variable. Number of threads will simply take the, or will be in a wait state of this countdown object. So this is the main method. So let me create thread. So countdown thread. Okay, and this is countdown thread 1. This is equal to new countdown thread, and if this thread is taking an object of, so first we have to create an object of countdown. Okay, sorry, what is happening here? Label. So this is countdown. Okay, and this is countdown, new countdown. Okay, we have created an object of countdown. So this countdown object will be passed to the thread 1. So this is countdown. Now same thread 2 we have created. Let me create another thread, and this will be called thread 2. Okay, now we have to assign the name to both of them. So countdown thread dot set name, and that should be what, very similar to this one. Countdown thread 2 dot set name, and this name has been given as it is name, otherwise it will not switch. Okay, let me give the gap over here also and here also. Okay, so this may be similar. Now the both the thread have been given name, and now let me start the thread. Okay, countdown dot thread 1 dot start, and countdown thread 2 dot start. So you can see clear we are taking an example of thread variable, and which is thread variable, it may be of type primitive type or object type. So let me create a variable of type countdown. So we have created a class for countdown. What this class is doing, this class is simply have a method do counting, and it's simply doing a counting from 1 to 10. Here we have taken a switch variable, and as number of threads, it will be assigned based on thread name, thread 1, thread 2. So to identify which thread have been assigned this method, simply it will take choose the color, and based on the color it will simply execute, and as whatever color it will take, the string variable, this will have a simply the thread name as well as the value of I, so that it is simply to identify which thread have been allocated this method. Okay, now the object of this class have been created, countdown, and this object is shared by two number of threads, thread 1, thread 2, and both the threads have been started. So let me try to execute this one. Let us see what happens. We have taken a separate, okay, so you can see now this one, third one, it clearly working all, so it is simply yes. Now most of the time it appears that both the threads are working very fine, but you can see here the thread 1 is starting 10. Now thread 2 is I0, I1, I2. Now both the threads have been rescheduled, or scheduling has been taken place randomly, and the results is simply unpredictable, and thread 1 is doing I0, next time it is taking 1, 2, and this. Let me run again. Okay, this time it has somehow doing done good. So this is all about what we want, a fixed result and predicted result, and a result as per our expectation. So what is happening here, both the threads are getting allotted this object countdown, and sometime it is getting allotted and the scheduling is done very fine, but sometime it simply allocate in a mixed way or in between. So this simply gives an unpredictable result. So this is simply unavoidable, and how we can avoid? Once the thread 1 is allocated this countdown object, the thread 2 will be in a wait state. As soon as it will see the countdown object is relaxed, it will simply give it to thread 2 and it will start the work. On the case thread 1 will be in wait state, so this will be a race condition. So how we can avoid this? This countdown object is in requirement and its method do counting. This uh, uh, is in critical section of this, you may say, but because as we have seen, this run object is doing what? It is simply calling the method do counting. So this do counting method is simply critical section or shared section of both the threads. So on that case, this will be in a, and as soon as this will locate, this will be give the result. So this is a critical section. So synchronization is a process by which we are simply a statement or a method is simply shared, synchronized, so that it will declare that this method will be allocated to a fixed number of. So here, what we are we're going to do to avoid the race condition, we are simply synchronizing this block. So how we can synchronize? So let me try a use. Now the method is now synchronized. So what will happen? It will allocate this method to thread 1 or to thread 2 at a time. This will not be allocated to any other thread till the work is getting executed. So let me do, try to run it. And on that case, you will see the results is very fine. There will be no mixing at any time. All the time the work will start and the thread will be allocated to. Okay, so you are seeing that the thread 1 and through 2 working in a synchronized manner. Once the object is allocated to thread 1, it is not allocated to thread 2 and it will be in a wait state. After getting allocated to thread 2, it will not be allocated to thread 1 in between till the work is over. So this is all about synchronization work. So this simply harms or hamper the speed or a performance of the program, and we should avoid synchronizing the block, and it should be restricted to the only very critical section of a method, the method which is required very critical or it will be shared, only that method need to be synchronized, because as the method thread 1 has been allocated this one, the next threads will be in wait state and the work given to them will be in a halt state and all the threads will be in waiting. Suppose if it is exceeded more than twice, so it will simply try to attempt to get the lock at because there is no any way it is keeping the lock of this method, but it is not and next threads are not getting aware that the which one thread will keep the this method synchronized up to which time. Okay, before going ahead, let me try to make this, and above this where in this method the most critical section is this for loop, because thread 1 and thread 2 both are separate here, and based on the thread 1 this is the color getting allocated. So rather than keeping a synchronization of this one, let me synchronize this. Which one? Color. And here we are keeping this one. Okay. Sorry, rather than making color, we have to make this one this. Why so? Because it will simply allocated, this will simply denote the current object. Object of what? This will be object of color. It's the object of type string. This is the color. Okay. So this will simply denotes the current object allocated to which one thread. Okay. So here we have done what? Synchronized a block of code. And here rather than synchronizing this do counting method at all, We have simply synchronized this for loop, and as I told you earlier, it is always we should take always precaution while making the synchronization of a code, because it will simply hamper the speed or performance of a whole program at large. And making a synchronization of methods as many as it will simply hamper. So we are simply, rather than doing the method as synchronized, this is where we are hampering, we are making a synchronization of this for loop only, and let we run it. You can see this is the for loop is critical section, and it is allocated and it is synchronized. So each time the for loop will be allocated to only one thread. So there will be no any chance of thread interference. And if thread interference will not be there, there will be no any kind of problem while execution. So as many as times you are seeing, the result is quite consistent, and the counting is getting done by both the threads, and it is clearly visible by as the color is allocated by cyan and a purple. So this is all about synchronization and thread variable. I hope you might have got a brief idea and concept about the thread variable. So thread variable is a variable that is required by number of threads, and if it is scarce or if it is shared by a number of threads, there may be a thread interference. To avoid the thread interference, we are simply doing synchronized either the method or the block of a code. But we should have a very cautious about the synchronizing the block of code, because it is simply hampering the performance of the system, as number of threads will be in a wait state, and they will simply halt their work in search of the required resource. So there should be a method that if any thread is keeping or having the method lock, what it is means, synchronize is doing what it is simply keeping the lock of this method to someone, or the allocated or the thread which have been given the lock of this code. So once the lock is getting released of the object intrinsic lock, so on that case, it should be acknowledged by the acknowledged to threads which are in a wait state. Or you may say that once that lock has been allocated of any object to any thread, that should be given till the work is over, and once it is released, it should be acknowledged to number of threads in a wait state, so so that they will now given, or they will attempt to get the lock of required resource. So there is a method wait notify all, that we will take in the next lecture. That is quite important, because as much as time the thread lock is kept by some thread, the number of threads which are in wait state will try repeatedly uh, again and again, and they will simply attempt to, and this will simply, if number of threads are there, you can't imagine how many attempts will be there, and this will simply take a huge and precious resource of a system, as well as hamper the performance of program. So a condition is very quite very difficult to understand, but let me try to understand. So we will try to understand in the next lecture. So till then, keep continuing, keep reading, stay tuned with Java City, and bye for now.